Morning. So I'm going to talk about API gateways, the good, the bad, and the ugly. As part of this presentation, I'm going to talk to you about the problems that we have solved by using an API gateway and why we think it's an important part of architecture. We're going to talk a little bit about what features an API gateway offers. We're going to look at some of the potential low-level details, though, because although API gateways are great, there are some real problems with using them as well. We're also then going to talk a little bit about how we test with gateways, a little bit about chaos engineering, because once you start introducing gateways, you've got failure in many places. And then I'll talk about some of the anti-patterns and solutions as well. So who am I? My name's James. I'm a software developer, and I'm also the author of a book called Optimizing Java. Java and open source is a real passion of mine. And I'm a contributor of open source to both Java and the Maven project. One of the things that I actually worked on in Java was the new date time API in Java 8. My day job, to fund all this open source work, is building API client solutions at Morgan Stanley, and API Gateway has been a big part of that. I'm also particularly active in Java user groups. So what does it look like without an API gateway? Well, everybody wants to move towards a microservice architecture, and people are tending to move in that direction. So in this example, and in the sort of the demonstrations that I'm going to give, we're going to assume that we're building something for a conference, a very simple system. And obviously this has got 3 different components. It's got one for sessions, one for speakers, and maybe to get hold of some tickets as well. Now, probably we want to build a conference website to be able to allow our attendees to access the details of the upcoming sessions. We may also want to make a conference mobile app. Now, the problem with this is that as soon as you do this, you end up in a situation where your clients have to know a lot of details about your infrastructure. They have to know where the sessions are, the speakers are, the tickets are, and you end up with kind of lots of different connections passing through your firewall. Now, it's very likely that your architecture is actually more complicated than this, because as we know, the whole point of microservices is that you can horizontally scale. So you end up having to put in load balancers as well. So you end up in a situation where you have a lot of your network topology exposed to your external consumers. Now, if you want to build an API program off the back of this, or you want to actually give your clients access to those APIs directly, then things start to get very difficult. So the clients are coupled to the knowledge of how you've deployed your servers. The problem with microservices is that the problem and the benefit, I should say, is that you want to have this really fast change. And when you do that, you potentially expose a maintenance issue if your clients access them directly. And that comes into something around multiple versioning and semantic API versioning. This then becomes really tricky, and you may end up actually doing some kind of big bang release, which nobody wants to do. We're trying to move away from that. That's what all the DevOps talk was about this morning. You increase the number of holes in the firewall, which scares our security people. And then your services, they now have to handle a lot more. Your microservices have to handle SSL, authorization, logging. It's not a very good picture without an API gateway. So when we put an API gateway in place, we get a lot less arrows, which is usually a good thing. And we are now connecting through to those services in the background. So this is all quite cool. But one of the confusion points that I've seen whilst we've been working on API gateways is the different types of API gateways that you can actually have. So these broadly fall into 2 categories. There's the enterprise level API gateway and the microservice gateway. Okay? And the microservice gateway is the one we'll mainly focus on today, but I think it's important to separate the 2. Now, this table is based on Ambassador, which is an open source Kubernetes native gateway. So the goal of an enterprise level gateway, that's to give you a marketplace. It's to give you the centralization of all of your different APIs that you run across your organization, all that you publish to your clients. And microservice gateway is much more about your internal services. Okay, and that's quite an important distinction. When you deploy to the enterprise gateway, it's very likely that you do that through an admin user interface. So if you ever played around with things like Apogee, Azure, maybe even Kong, some of the more popular API management solutions, you tend to use an admin API. Whereas the whole point of a microservice gateway is to be able to drive your DevOps initiative. Now, if you have to use an admin API every time you release a change, you're potentially going to get in a place where you're trying to do microservices, but you get stuck. Now, when we talk about the metrics collected, when it's on the enterprise level gateway, it's much more about how often is the client making requests, what kind of responses are they getting back. Whereas on the microservice side, you're more interested in latency and traffic measures. You want to know, should I be horizontally scaling this system further? When we have errors are probably like the most important thing, in that we don't want to give our clients all of the error details that have happened in the internal systems. One of my examples that I'll use later on sends a stack trace back to the user, which is not good. Whereas in the microservice gateway, we absolutely want to know every single thing that's gone wrong, so we're able to debug and fix that problem. Now, when it comes to testing, you're much more likely to, in the enterprise gateway, have a staging and production promotion that goes through maybe a sandbox environment and a pre-release environment. When it comes to the microservice gateway and your microservices, you want to be able to do things like canary deployments, maybe Dart deployments, all these kind of cool things that really enable and drive DevOps. And then finally, if you were developing with these, the idea is the microservice gateway, you probably run it on Docker or maybe Kubernetes if that's your chosen platform. Whereas the enterprise level gateway, you may not even run that locally. But if you need it to, an enterprise gateway would be there inside Docker. So I think if there's one thing to sort of take away from this part of the talk, it's that API gateways are, they're really great. However, if you mix these two concepts and you put your enterprise level gateway and microservice level gateway together, you're potentially not going to get as many of the benefits. So what it tends to look like is you have an enterprise level gateway that is where you deal with your security concerns. You deal with showing the developers externally to your organization the actual APIs that you offer. And then in the background, you've got the actual microservice gateways that are usually aligned with a squad or a team. So I own my own gateway within my team, for example. And if somebody else within the company wants to add something to the external API portal, well, that's cool because they can create their own microservice gateway too and add that in to the bigger level strategy. Now, the features an API gateway offers is also an interesting one. And obviously, you've got competing products out there. Reverse proxies are one example. Now, a reverse proxy you would usually use when you want to replicate a front to a particular service to avoid things like denial of service attacks, potentially just to terminate TLS and SSL. So it's usually just one service that's behind the scenes. The other question I often get asked is, well, why wouldn't you just use a load balancer? Because in many cases, that might be all you need. So a load balancer really gives you the SSL capabilities, but it's got multiple back-end support and service discovery. So load balancers are also a good viable option. Now, when it comes to API gateways, you get a lot more out of the box. One of the gateways that we'll look at later is the Spring Cloud Gateway, and that gives you quite a few features just without having to do any code, really. You can do most of it as configuration. But you can do things like API composition. So you make an API for trades, as an example, actually be sourced from multiple different services from downstream. You've got things like retry logic. And in microservice environments, especially on either private or public cloud, where services aren't guaranteed to be running all the time, you all of a sudden run into a lot more network noise than you might imagine. So you end up having to do plenty of retries as part of your actual processing. It also supports things like logging and tracing. And tracing is also one of those complicated things when it gets to microservices. How do you find what your system's even done? It's always an interesting question. Can you deterministically say easily and quickly which service even dealt with the request? So gateways themselves, they naturally lead to a more API-centric architecture, and especially when it comes to reliable APIs, you need to have a versioning and release strategy around what you're doing. You want to be able to create a minor update without impacting your consumers. So the idea is you can move from version 1.1 to 1.2, and your client doesn't have to change the code that they have generated to be able to consume your API. Now, when it comes to rate of change and trying to run an API program, DevOps automation is a real key driver, and getting this right from the beginning is important. And there's one reason for this. There are a few reasons, but one main reason, and that is a loosely coupled architecture is more difficult to test. Okay, you no longer know when you compile your code that it's 100% going to work. So by sort of coupling testing and automation, you can start to really gain success from this style of architecture and this style of approach. So within sort of architecture, API gateways are important for promoting API-centric. You build your APIs as microservices, or you can build them as SOA services as well. At that level, it's kind of down to what best fits your business requirements. And you drive velocity at the microservice gateway, and you hold your repository of what's available at that top-level, enterprise-level gateway. And this pattern is easy to extend, and you can rapidly build out an API program quite quickly if you can model this. However, one of the things that comes with being able to do this quite quickly is that, of course, not all problems are architectural. And then we have to start to think about the idea of API governance and curation as part of that. Because if you can give somebody any API, you might end up with 10 APIs of the same thing from different teams. So that's one thing to just be careful of. Now, gateways have a role in migrating legacy applications. I often get asked the question, hey, Jim, we want to change this service or move this service, but we don't have time to rewrite it towards SOA or microservices. And using something called the strangulation pattern, which if you have read books or read blog posts by Martin Fowler, this is one of the things that you can do to start to move parts of your functionality away from your monolithic deployment towards something like SOA or microservices. So the idea is that you can utilize an API gateway to start routing to your legacy service. And that could potentially be a big first step. And then you start to write newer or even business-critical functionality into your more modern ecosystem. And eventually you've migrated enough that you can then start to decommission the system that's your previous legacy. So things don't necessarily have to be big bang. You don't necessarily have to go to this kind of pattern straight away. Gateways have another important role in migrating applications to cloud. Now, if you work in a big organization, it's quite likely that you'll be familiar with some of the challenges of moving to cloud. Things like you've got your own custom authentication that you potentially use within your organization. There might not be standard libraries. You might have built out your own sort of libraries that depend on different things that are just not available in a cloud-like environment. And entitlements start to become a challenge as well. Now, what you can do with gateways is you can start to do some of the transformation at the gateway level to start to introduce more of the cloud-like concepts. So, for example, we terminate OAuth 2 at the enterprise-level API gateway, but in our plans, it's to move the OAuth 2 token further down through the system. And as we start to understand more about how this protocol works and how it fits in with our end services, and we begin to move away from some of these internalizations, then we can start to then potentially move those services out to cloud as well. So it all fits in with part of the strategy. It's all kind of a nice warm feeling at this point. However, the talk wouldn't be called the bad and the ugly if I was here just to give you a sales pitch on API gateways. This is an interesting article from something called the ThoughtWorks Technology Radar. Now, the ThoughtWorks Technology Radar has recommendations about different technologies and where they currently sit in industry. So API gateways last appeared in the radar around a year ago, and this was the concern that was raised. API gateways are open to adding in code. You can add code into API gateways, and we'll see some of that shortly. However, if you can add code into something, it means you can start to add features that are maybe not necessarily concerned with routing, service discovery, and all of those great things that API gateways give you. So what that's led to is an abuse of API gateways to kind of especially within the vendor community, to provide API gateways that sometimes become overambitious. And they do more than perhaps is what you want at that particular tier. So that's certainly one of the words of cautions that I would say, is you have to be careful with what you actually build into your gateway products. Okay, this is another thing that causes an issue from a technical perspective and a sort of actually looking at this system. So in the example, we've got a request that comes in to find out details about a speaker at our conference. So a speaker is also an attendee. So we go to the attendee service and say we're looking up information about Jim. And what the attendee service needs to do is go to the user details service to say, can I have the information about Jim? Now the issue is attendees is kind of, the person writing attendees goes, okay, well, I need something that solves service discovery for me. I need to know where the service is located. So the problem emerges that actually you can loop back through the gateway to find out that information. And the problem with looping back through the gateway is now you've got an issue where for every request you're starting to use 2 resources on the actual gateway itself, which kind of ends up in a little bit of a mess, and that's what I want to try and show you in my first demo. So in this demo, I'm going to use a Docker Compose file, and this Docker Compose file has 3 different systems that it's going to fire up. It's going to fire up a good and bad and ugly gateway, which I've written in Apache Camel. It's about 7 lines of code, so these things don't have to be complicated. I have a user details service and an attendee service. So we'll fire this up. So I'm doing that one-handed, so a little bit awkward. So we'll run up this service, and I'm going to use something called Apache JMeter to simulate requests against the actual gateway. Okay, everything's started, so we're hopefully looking quite good. Now, inside JMeter, I can simulate concurrent users. So what I'm going to do is I'm going to put 10 users to just show you this working. We're going to just do, the loop count won't matter because we won't watch for that far. And I've got 2 variables that I'm actually applying to the service here. I've got one which is number, and that's the number of requests that will go between attendees and user details. And then I also have a simulated delay on the user details service. So that's a delay of 1 second. And I can tweak that around to give me different ideas of how this API gateway will behave. So if we start off the simulation, you can see the thing's moving in the background, so it's definitely not, it is definitely real. And we can start to have a look at the graph of these users hitting the service and get an idea of how long this is taking. So we've only captured 1 point so far, and it's around 2 seconds, just over 2 seconds for this to return. And we can see now it's around 2.1 seconds. So this is really great. However, this is where you're lured into a false sense of security, because you think this is all working nicely. Now, what I'm going to do is I'll show you some graphs inside my slides that I captured this morning to avoid any disasters whilst trying to demo and my laptop potentially going a bit hot. So in this first example, you've got 50 concurrent users making 2 requests internally with a delay of 1 second. So you can already see that going from 10 to 50 concurrent users, you're up to about between 4.2 and 6.3 seconds in that average response time. So things are already starting to look a little shaky at 50 users. Once you move up to 100 users, you start to hit a real problem. So this red area here, I've tried to highlight this because this is where most HTTP clients will probably cut you off and not actually finish the request. So 100 users, things are looking really bad. And if we go to 150 users, in some of these instances, you're waiting more than a minute to get your responses back. So the effect of users and the effect of loopback on the gateway, it doesn't take very much for this to become an absolute problem. Now, just for fun, I decided to try the same simulation with 200 users and no delay. Now, no delay means that you're actually pushing a lot of data through and traffic through the gateway. So in many cases, everything looks just fine, but then you're starting to put pressure on the JVM and the subsystem, and you can then get spikes. And you can see the graph catching up with itself after it has that effective pause. So it's one thing to definitely be aware of. And one of the things I wanted to point out was a couple of solutions to this problem. So you can enforce timeouts and circuit breaking policies. So if something goes rogue, the problem with gateways is they are single points in your architecture. That's both a problem and intentional, okay? But you need to mitigate against that single point of failure. So if a service goes rogue, you need to cut it off so no other services get impacted. Now, you could also try and resolve this with an external and an internal gateway, which is what we tried to do to begin with, but you very quickly run into problems where people either use the wrong thing, they don't understand the policy, and you end up back in the same problem. Now, what if attendee service could access user details directly? So that's one possible solution with two different ways of solving that problem. The first is to use client-side routing from the Netflix stack. Another is to solve this using a service mesh. Okay, now, if I would say one thing about API gateways and the landscape here, service mesh is the way that things are moving towards very quickly, especially in the open source space. Okay, so in this example then, you've got your mobile application. It connects through an API gateway, which might be using something like Zool. You have service discovery from Eureka. You've got Ribbon on the attendee side, which does client-side routing now, and it's able to find out where user details is from service discovery. And you've also got Hystrix-level circuit breaking on the microservice itself. Now, without getting into the details of definitions of microservices and that kind of thing, because that's a whole different one-hour topic, the problem with attendees is it now has to know an awful lot about the architecture in which it's deployed. Sure, you get a lot of this information out of the libraries that support this, but you're kind of starting to blow out what your applications do. So this is where service meshes come in. And what service mesh allows you to do is push a lot of those concerns that we've just discussed back into the infrastructure level. Now, these slides are going to be based around a product called Istio, which is built on top of Kubernetes, which starts to really explain what a service mesh is. So a service mesh has something called a control plane. And typically the control plane is all about handling the rest of the system. It's kind of the pilot in this example here. It does things like service discovery, and it knows where all of those components are running. It's able to do traffic management and give you resiliency. And behind the scenes, it's using a router, which we'll see called Envoy, and is able to convert all of the different policies into Envoy rules. Okay, so that becomes quite an important piece. Now, as I mentioned, it's really difficult to find out what happened to your request, what happened to that particular failure that we saw inside our metrics. And the mixer is able to do this. It's the component that brings all of the telemetry and data together and enforces some access control as well. So we'll see how that kind of fits in. And then finally, I don't know if you've ever had this problem where you're trying to move towards TLS or MTLS, and you don't have a solution for that necessarily in your application. Well, you can also push that back into the infrastructure as well and hold your certificates within the mesh to solve that problem. Now, when it comes to the data plane, your attendee service, it's just the same Spring Boot application that you wrote before, wrapped inside a Docker container. Now, because you're running in Kubernetes for Istio, you also have this thing called a sidecar. Sidecar is, again, it's one of those patterns where it's really starting to emerge as the way to do common concerns within microservices without having to repeat them in every service. Now, again, you have to be careful with that because it's open to abuse. But in this example, the attendee service is now deployed with its own router inside the same pod. Now, what that means is that the router itself can intercept the traffic that attendees is making and make decisions about how to route it. Kubernetes has a feature called the auto sidecar injector, which allows you to switch this on with just a couple of lines of config. Now, that's actually quite a nice thing because if you're already running on Kubernetes, you can enable a service mesh with 2 or 3 commands and get some of the benefits straight out of the box. Now, the other thing that makes the data plane quite secure is the idea that there's still a front proxy or a gateway that is in place to route traffic into the mesh. There's also an egress policy as well, which means that you have control over traffic that leaves the service mesh. Because everything effectively has to go through your Envoy router, you're in full control of how this would all work. So the service mesh, it just removes gateway loopback. But more than that, it helps you to create a structure around your routing and traffic management rules. So it's very easy to do things like, I'm about to create a production release, but I want to mirror the traffic onto the new container so I can see what it's actually going to do within my environment. The API gateway is still an ingress point, but it gives you out of the box the benefit of tracing, monitoring, and capacity management. And the developer, the best thing for the developer is they just build their APIs, and you push this concern into the infrastructure. So Istio out of the box then, it has things like service discovery, load balancing, and TLS termination. It also supports quite a great deal of protocols. It does things like circuit breaking and health checks, and it has this idea of staged rollout with percentages as well. So you can control the traffic to say, like, send 10% of my traffic to version 1.2 and the other 90% to version 1.1. You can also do that on a user-by-user basis, and you can also do that on particular browsers. There's a whole range of rules that you can write there. Now, these are just some examples. I did a demo of Istio last year at a conference, and these are just some of the things that I captured from that demo. You can get a dashboard straight away that tells you your overall application or your overall service mesh health. You can get information about workloads and what kind of response rate that you're getting. So for operational level support, this stuff is really quite good. And probably by far one of the best features for developers is the ability to find every single message that's gone through your system and know 100% where it went and what went wrong. So although API Gateways introduced some challenges, Service Mesh certainly does go a long way towards resolving those, and an API Gateway is still part of the way in which that's all working. Now here's another potential risk factor when it comes to API Gateways. My demo gateway, I built it myself, okay, and it's built on Apache Camel. Now, inside Morgan Stanley, we built one of our own API gateways, and we had internal reasons for having to do that. We're in the process of also potentially looking to use something like Spring Cloud Gateway at the moment. Now, once you build your own gateway, the challenge is not so much the technology that you built it in, but having a low-level understanding of how web servers work. So having to understand Jetty and Netty is quite key. And the reason is because as soon as you start to scale, your ideas around things like back pressure and buffer capabilities and capacities, that comes in straight away. If you've built your own gateway, you're going to spend a lot of time building out filtering and logic behavior that's now available in many of the open source gateways out of the box. So my advice would be pick up an open source microservice gateway and contribute back unless you've got a very strong reason not to. Okay? Gateways themselves are single points of failure. Okay, you have to think about this. If you're whether you're building your own or deploying your own gateway, this is an important concern. So what can happen to the API gateway? Well, the box that the API gateway is on can go down, or the service in the background can go down as well. So you are going to have host failures or data center failures. So in our architecture, we mitigate this by having multiple gateways deployed behind a load balancer. It's one of the things that you have to really do. And then we don't use a load balancer anywhere else in our architecture. We just do that so we can horizontally scale the gateway. Two important measures when it comes to gateway: throughput and latency. Okay? So we were actually looking at the latency of requests in the previous graph. One of the ways that I could have potentially solved that problem would have been to spin out 20 gateways. And then you've kind of got throughput that's hopefully, as you add another server, your throughput scales linearly. Now, another thing that we've had is actual network failures as well. So network failures are common, either, again, when hosts go down, but also just as part of potential DNS or low-level migrations. So you've got to make sure that out from your particular gateway, you're not just dependent on one channel or one path. Service discovery, well, we've actually had a situation where service discovery has gone down as well. And that's interesting because you end up in an inconsistent state. So your routing table is no longer up to date with where your services are currently deployed. Now, the way that we've mitigated this is our application the gateway will continue to run and make a best efforts basis on routing, but because it's got retry logic in there, it's able to retry across different containers should you have service discovery failure. If a new gateway starts up, which it may do because one may have been evicted, it actually doesn't allow that gateway to go into rotation because it cannot get an accurate state at that time. So we've had to try and think around all these different conditions. The final one is authentication failure. And unfortunately, if that one goes down, all bets are off. Because if you can't authenticate to another service, you're in a bit of a mess from there. So there are many failures within the ecosystem that you've got to take into account. Okay? It's like anything. There is no such thing as a free lunch, really. Now, here's another demo, and I like this demo because we only found out about this in production. Okay? Now, you never want to find out about a problem in production. So I'm going to talk to you about how you can mitigate this, as well as some of the problems that it caused. So for those of you that are familiar with REST, can a RESTful delete have a body? Okay? So I can see a couple of people nodding. Okay, so this is an interesting question. Now, the answer is yes, but it depends. It's actually the semantics are not defined. This is like going back to the old C++ specification days. And actually, many clients won't allow you to send in a delete. So, a payload with a delete request has no defined semantics. So some things will allow you to do that, other things won't. In the latest, this is a conversation from Stack Overflow, which is kind of interesting, where people are disputing the spec has actually changed to say that they remove the requirement to allow you to have a body, and then the new spec, RFC 7231, comes out and says it's back to being no defined semantics for deletes having a body. Okay? So it's quite a peculiar one. So I want to show you this as a demo. So in this first example, I'm going against localhost user 4. This is the Spring Boot implementation of a microservice. So if I hit this service, I get a 200. And in the background there, you probably saw a flash of console log. It's picked out the test user, test email, and 2020. I must have been thinking about next year already when I created that user ID. Now, in the second example, I'm going to go against user/user/4 on 8082, which is the Camel implemented API gateway. So if I go against the Camel implemented API gateway, I get a server error. Because actually, Apache Camel can't by default, it doesn't by default, there's a caveat to that, doesn't by default support deletes with a body. Okay, so it's kind of interesting. And you do get this issue then where if there are edges of the spec that don't quite line up, you run into a problem. So how do you mitigate hitting that in production? And this is where I want to introduce a concept called test containers. So if you're using Docker, a test container is a way of introducing infrastructure within your local integration tests. Okay? Now what you do is you use a Docker container, and that Docker container has in it potentially something like a database, potentially something like an API gateway. So what I did was I created a test container for Spring Cloud Gateway. And what this allows me to do is supply an application.yaml file with the routing information for the gateway. And what we end up seeing, if we just go through this demo, so what I've got here is I've got what's a generic container. So there are certain containers that are available out of the library of test containers for free. Or they've already been built, so obviously not for free, someone spent time on them. And in here I'm pulling from my Docker repo the vanilla Spring Cloud Gateway. I'm doing a little bit around IP mappings. That's mainly because Mac and Windows and Docker don't play nicely together in terms of consistent IPs. It's one of the interesting ones, actually, because within Docker Compose, that problem is somewhat solved. Now, I have a delete request here. I'm using the Spring REST template. Because it's not, again, delete with a body is not supported on the template from Spring, I have to do an exchange, which allows me to do that behavior. Now, if I run these tests then, what you'll see is that the application starts up, or the testing is starting up here, and I'm launching the Docker container. So I launch a vanilla Spring Cloud Gateway, and the test itself also launches inside a Docker container. Okay, so you end up running your integration test between two Docker containers on your system. I mean, by far the coolest thing about this test is the little Docker whales that appear in the log file. I think that's quite cute. It's the simple things, right? So that gives you the ability to know immediately that your test is going to fail locally. It means that we don't support that behavior. Apache Camel does actually now support that feature from Camel 19. So there's an optional flag that you can use to allow deletes to go through the HTTP client. But it's an interesting, REST seems really simple until you hit all the problems, is what I'm trying to say. Now, there is a role in end-to-end testing. So there is some things that are really hard to test locally. Things like performance and security, impossible to test locally in some cases. Now, we utilize ephemeral testing to help us mitigate issues before production, and those ephemeral tests run as part of our built pipeline. So we are able to simulate all of the different success criteria under which we want our API gateway to operate. Now, I mentioned we've built our own gateway. One of the things around that is, although we built it ourselves, it is an inner source product that other teams are also benefiting from within the organization. Now, ephemeral testing helps us get started with things like chaos testing, which is an area that we're looking to explore as well. Now, when it comes to testing, though, I think it's really important that you get the right mixture across the test pyramid, because you can often replicate or reproduce tests that then have no meaning elsewhere within your test pyramid. So that's something we fell into the trap of doing too much testing almost. I always say you can never have too much testing until you've got too many and they're all failing and it's difficult to figure out what's going wrong. So in chaos engineering, our plans are to start to measure what our steady state is with a gateway. And this is something that we've been able to model inside our ephemeral environment with production the next on the plan. You look to make a hypothesis about steady state inside your control group and your experimental group. So your experiment that you're about to perform is where you're planning to do something nasty on purpose and hope that nothing impacts production. That's what you're trying to essentially assume. You want to introduce variables, and then you have to look and try and disprove the hypothesis that you put in place. So when I talked about the different areas of failure, I mentioned that authentication failure is disastrous. We would say that that has a blast radius of the entire system. And part of what we're trying to do with chaos engineering is look at how we can mitigate against high blast radius outages. So anti-patterns, and like all technologies, APIs, they're subject to misuse. You've got to avoid overburdening a single microservice gateway. They should be easy to provision and deploy, and you want to have those on a team-by-team basis if you can. The other problem that kind of comes in with loopback is your gateway becoming an enterprise service bus. So if you've got lots of services talking to each other through the gateway, you should probably just use an enterprise service bus. So be careful within your architecture that you're using the right thing for the right job. So in conclusion, microservice gateways help you to coordinate APIs and API-centric architecture. I mentioned, my role at Morgan Stanley is about delivering APIs to clients, but we have had to get into all of these pieces around API gateways to move our organization in a way that could support an API architecture that scales. Do use an enterprise API gateway to give that external value to clients, and use gateways within your architecture for a benefit. Don't use them as enterprise service buses. Be aware of the single points of failure and where you can have problems, and use testing and best practices, and make sure that you've thought of the fact that maybe if you don't test things now, you absolutely definitely need to test them in a microservice world, because you're decoupled and potentially going to cause yourself a lot of problems if you don't. Okay, thanks for listening.